Okay, here's a couple of questions that involve exponents, maybe a little bit of logarithms. First question they ask us to solve. So they want us to solve that. I've got two factors over here, but it looks like I can get them to be a common base. 27, 3, and 9, they're all powers of 3. So maybe let's go with that angle. So 27 is 3 cubed. 3 to the 5x I'll leave as is, times 9 is 3 squared to the x squared. I'll maybe put that in brackets for now. Go x squared like that. So 9 is 3 squared, x squared is there. Let me just rewrite it. So 3 cubed equals 3 to the 5x times 3 to the 2x squared. If I'm multiplying common bases, I add exponents. So 3 to the cubed equals 3 to the 5x plus 2x squared. Now that I have common bases, and there's just one base on each side, then I can equate exponents. So this 3 up here will be 3 equals this exponent over here. Okay, now it's looks like a quadratic equation, so I'll get everything to one side. I'll just rewrite it so it's in the right order. Minus 3, and then from there factor or do whatever you need to. I think it's 2x and x. I'm thinking a plus 3 and a minus 1. 2x squared plus 6 minus 1. Yep, that's it. So then here 2x minus 1 equals 0, because something times something equals 0. You can equate either of them to 0, or x plus 3 equals 0. So in this case, if you take the 1 over and divide by 2, you get a half. Here you get a negative 3. Then I'd go back and just check those to make sure they work. A half and negative 3. So put a half there. Negative 3 squared is 9. Am I doing this right? Negative 3 squared is 9 times 2, that'd be 18. And negative 3 times 5 is negative 15. So I have 18, negative 18, no, 18 and negative 15 is positive 3, and that's what I have on the other side. So that one works, and I probably should check the other one too. Anyway, that's how you do that one. Here's another one. This one is a little bit tougher because I don't think there's any way I could get a common base. Like maybe I could change this 10 so that it's 2 times 5 to the minus x. There's a times in there. Equals 5 to the 2x. And then this is a power of a product. So I could rate that as 2 to the minus x times 5 to the minus x equals 5 to the 2x. Divide both sides by 5 to the minus x. I get 2 to the minus x equals 5 to the 2x divided by 5 to the minus x. 2 to the minus x, dividing common bases, subtract their exponents. So 2x minus a negative x would be 3x. And really, when I look at it, I don't see that there's any much difference than the first one. I still have something to the x, something to the 2x, or 3x. It's not a whole lot different than the last one. I guess now that I have, well, I could have done this at the start too. I could use the power law and log both sides. So log 2 to the minus x equals log 5 to the 3x. Using the power law brings that negative x down front, times log of 2 equals 3x times log of 5. But when I'm doing this, I'm sort of finding that, I don't know, like it doesn't really matter what this is. Log of 2, I don't know, is point something. Let's call it 0.1 minus x times 0.1. And over on this side, log of 5 might be 0.2 times 3, it might be 0.6x. But you take a look and you have x's here. Even if I brought them over to this side is equal to 0, I'm going to be dividing something on this side and dividing something on this side with the x there. It's just going to come out to x is equal to 0. I probably could have seen that right off the bat too, because the only way I really could plug a number in there and make one side equal to the other side is if that x was 0, because anything to the 0 power is equal to 1. So if I have 10 to the 0, that's 1. If I have 5 to the 0, that's 1. So really an x value of 0 is the only option for that particular question. That's a tough one. Next question, don't worry about the e's. You have to, it's one where you say e to the 2x is x squared or something like that. So don't worry about those kind. But here's a great log question. So here I've got log of x plus log of x minus 9 is equal to 1. So I see a plus there, so this is the product law. I can rewrite it as 1 logarithm. That's the product of this times that. So it's x times x minus 9. Okay, is equal to 1. No base indicated, so I assume it's a 10. So I could change from log form to exponential form. So it'd be 10 to the first is equal to x times x minus 9, or x squared minus 9x. 10 to the first is simply 10. Looks like a quadratic. Let's make it equal to 0. And then see if I can factor it. I'm thinking x minus 10, x plus 1. That's what I'm thinking. X squared plus 1 minus 10, that's that. Yeah, that's correct. So by the 0 property, this times this equals 0, so one of them has to be 0. So x minus 10 is equal to 0, or x is 10, and x is a minus 1. So those would be my two answers, but remember I have to go back and check in the original question and make sure I'm not taking the log of a negative number. If I put a 10 in, log of 10, that's good. 10 minus 9, that's positive 1, that one's okay. But if I put a minus 1 in right here, or a minus 1 right there, I end up taking the log of a negative number, and we said that that's not allowed. So this answer can't be. Okay, last question, just some more practices. Seems like just like the last, oh no, it's different. I have a log right here. Whereas on this last question, I just had a number. So on this one, let's try and combine these again. So that would be log of x times x plus 4 equals log of 12. Now, if I have log of both sides, on both sides like this, and it has to be one term here, one term there. I can't have two terms like this one. I have to combine those. Log of that, I can drop the logs. Property of logarithmic equality. So I have x times x plus 4 is equal to 12. Foil this, x squared plus 4x. Bring the 12 to the left side. Minus 12 is equal to 0. Factor, probably x plus 6, x minus 2 equals 0. Is that right? X squared minus 2 plus, yeah, that's right. So again, property, 0 property, something times something equals 0. Either this is 0 or that's 0. So x plus 6 is equal to 0, so x is a minus 6 or a positive 2. Again, check up here to make sure that they all don't give me a negative logarithm. If I plug a minus 6 right here, I'm taking the log of a negative number. Can't do that. So immediately that one is out. But when I put a 2 in, 2 is all okay. So 2 must be the correct answer. Hopefully that helps you with some of your log questions.